Okay, so before we were just solving and graphing inequalities. Today and this week we're going to be graphing linear inequalities. So we need to go back to remember how to graph lines. So the lines that we graph are going to be our boundary line. And then what we're going to be doing is shading half of the graph, whichever side of the line will satisfy our inequality. It's either going to be greater than or equal to, or less than or equal to. And the difference between, say, a greater than or equal to, before when we graphed them, remember they were opened and closed circles. Now when we graph these linear inequalities, the plain greater than symbol is going to be a broken or a dashed line. But when we graph the greater than or equal to, it'll be a solid line. The same thing's going to happen for the less than symbol. It'll be a broken or a dashed line, and then the less than or equal to would be a solid line. So we're going to graph our boundary line. So here is our linear equation, our example of that. And if you remember how to graph back from our slope chapter, when we're graphing an equation, our first point goes, and this is in y equals mx plus b form. And if you remember that the number that's over here without the letter, that is your y-intercept or your b. So my first point would go 1, 2, 3. And then my slope of this line right here is a 1. So remember, slope is rise over run. So from this y-intercept, I'm going to go up 1 and then to the right 1. So my next point would be up 1 and over 1. Again, since this is an equation, it's an equal sign. Remember, you just connect your points and you would make your straight line. This is what we're going to be doing with these inequalities. We're going to change the inequality symbol to an equal sign so that we can create the boundary line. And then from there, we're going to shade either the top or the bottom or the left or the right, depending on the position of our line. So, for example, if they now change from an equation and then now change it to a greater than symbol, now what we need to do is, now that they've graphed our boundary line, which is right here, now we have to decide which side of the graph will satisfy y is greater than x plus 3. So then what you would do is, greater than is always usually going to be the top part of it, but what they recommend you do is you choose an ordered pair and you plug it in to see if you get a true statement. So, for example, if I think y is greater than x plus 3, that tells me that I should be shading the top because it's greater than. So I'm going to pick a point that's above the line. So for example, I always like to try to choose 0, 0. However, 0, 0 is not above the line. So any point in this blue area, I could choose to pick it in and plug it in. And if I get a true statement, then that's the side that I need to shade. If I get a false statement, then I would shade the other side. Now, if I were to have chosen 0, 0, watch what happens. So if I plug in the order pair 0, 0, this is x, this is y, is 0 greater than 0 plus 3, which is 3? Is that a true statement? No, it's not. So this tells me that the ordered pair 0, 0 would not be a solution for this, and the answer to my problem is this up top here, and you shade that side of it. So on your paper, this side, the red side, would be just blank. It would be white. Now, if it were less than what they have here, then if you plug it in and you now change that symbol, and now if you do 0 less than 0 plus 3, this is a true statement. So this equation or this inequality would be the bottom half of the graph. So you're going to graph a boundary line, and then you have to decide, do I shade the top or the bottom? Let's try. Here are the 3 different scenarios for that same thing. So again, when it's this symbol or this, notice this graph and this graph, notice the line type is going to be broken or dashed. When it's got a less than or equal to or a greater than or equal to, when you graph, it will be a solid line. So when you're taking this test, I'm going to be looking for the line type, that the line is graphed in the appropriate position and the correct side of the graph has been shaded. So notice on both of these where it's greater than or equal to, notice the top half of the line is shaded. And then when it's less than or equal to, the bottom half. And again, the way that you can confirm if you've shaded the right side is pick a point in that area and then see if it's a true statement. Let's try another example. Now, when you're taking the test this week on this, the equations or the inequalities given to you will not be in slope-intercept form. You will have to rearrange them first. So the first one here is 3x minus 2y is greater than or equal to negative 4. I need to get this into y equals mx plus b form. Now, if you'd like just to get your boundary line, you can change this symbol, if you want, to an equal sign. But then as far as shading goes, you need to keep it the inequality. I'm going to go ahead and just keep it the inequality, but I'm going to know when I make my boundary line, I'm doing it as if it were an equation. So I'm going to subtract the 3x, and I get negative 2y is greater than or equal to negative 3x minus 4. I'm dividing by negative 2 to all 3 pieces. This will now make my inequality symbol reverse because I divided by a negative number. This will now become positive 3 over 2x plus 2. And now I'm going to graph this as if it were an equal sign to get my boundary line. And then from there, I'm going to shade below the line because it's less than. Okay, so I know the graph is already there, but just to walk you through, my first point goes on the positive 2, so 1 on the y-axis. So I'm going to put my first point right here, and then from that 2, I'm going to move the slope. So my slope is 3 over 2, so I'm going to rise up 3. And then I'm going to run to the right 2. So 1, 2, 3, and then over to the side 2. Now, if you look at your symbol, notice it's a less than or equal to. So when I connect my points to make my boundary line, it's going to be a solid line. Now, I'm going to shade. Again, if you want to just remember that less than is below, you're going to color everything that's below the line for less than. Now, a way to confirm this is you choose an order pair. So if I take y less than or equal to 3x plus 2, I would pick a point that's in my shaded area. A point in my shaded area, the easiest one to check it with is 0, 0. So I plug in a 0 for the y, a 0 for the x, and then I simplify it. If I end up with a true statement, which I do, then I know I've shaded the correct section. You don't have to choose 0, 0. You could choose 1, 1. You could choose whatever point is in that area. Again, 0, 0 is the easiest one to plug in. So basically, we're going back to our slope-intercept chapter. We're going to graph our boundary line. And sometimes it'll be a dashed line, only if it's a greater than or a less than symbol. However, if it's got the underline, the equal to part, then it's a solid line. And then from there, you either shade above the line or below. Sometimes if your line's vertical, you might be shading to the left or to the right. It depends on the inequality symbol. So let's see what else we have here. So here are two examples when your line is either horizontal or vertical. If you recall back from the slope-intercept chapter, whenever your equation of the line is y equals a number, say 3, then your equation or your graph, and let me do this, I'll make the axis in black. And then if I were to graph y equals 3, then this would be 1, 2, 3. It is going to be a horizontal line through positive 3. And then if they ask you to graph y is less than 3, or equal to, let me add since I've already made a solid line, then you would shade or color below the line. Now again, you can choose an order pair. If I were to have chosen 0, 0 again and plug it in to this, notice there was no x, but I would just put in the 0 for the y. Is 0 less than or equal to 3? Yes, it is. So because I shaded or colored in the side that had 0, 0, I did it correctly. The same thing when it's x equals or x is less than or x is greater than a number. This time the line would be vertical. So this is all we're doing on this. You got to remember how to graph lines. So your homework for this is 1 through 33 all. Again, the beginning ones, if you notice here, these are just going to be either the first two here, y equals, this is going to be a horizontal line, and actually these will be a vertical line, and then they mix them up on this one, and then here is where you're actually going to graph an actual line. It'll be diagonally, and then you're going to shade above or below. So they start out slow, and then as you get over on the second page of the homework, you must put them in slope-intercept form before you can graph the line. So for example, on number 15, you would have to rearrange this first by moving the x over, subtract it, negative 3y less than or equal to negative x minus 6. Divide all three pieces by negative 3. It will cause the symbol to reverse because we're dividing by a negative, and this will become 1/3 x plus 2. And then you would graph the boundary line, and then you would shade either above or below the line. And in this case, it's a greater than, so you would shade above. Over here, where it's asking you to come up with the inequality, again, what I recommend you do is this. When you get down to this part of it, for example, let me do number 28. So for 28, let me do a different one where there's a different y-intercept. Let me do 31. What I recommend you do is whenever you see it's a diagonal line, you know you're going to have a y, you're going to have an x, and now you could look at the line type. So it's a dashed line, and it's below. So already I can see that it's going to be less than, not less than or equal to because it's broken. And then the next thing I'd look for is where does it hit the y-axis. So you can see it's hitting it right here at 2. So that's your y-intercept. And then from there I would try to figure out the slope. I'd count the boxes. So notice it's going up 1 and then to the right 2. So the slope here, rise over run, would be 1/2. So that's how you can do that part of the homework. Look for the y-intercept, figure out the slope, pay attention to the line type, and which side of the graph is shaded. So this is graphing linear inequalities. Any questions? So your homework is 1 through 33 all.